So in this video, I'm going to talk about the indirect substitution mechanism, also known as the Sn1 mechanism. So this mechanism is a substitution, and it involves the indirect replacement of a halide or any other leaving group. And most importantly, the difference between an Sn1 and Sn2 reaction is that the Sn1 is multi-steps. So it's more than one step. Below, I wrote the overall reaction, so essentially your starting materials and your products. And I highlighted the bromine and the CH3O in different colors, so you can essentially follow what happens. And so essentially, so these are your products right here. Essentially, what happens pretty much is that these two groups switch places. That's the overall mechanism. However, the overall reaction says nothing about the about the details, about what exactly happens. And so that's something we're going to talk about right now. So I'm going to tell you exactly how this occurs. So the first step in an Sn1 mechanism is that the leaving group is going to dissociate. So this molecule is going to turn into two different things. So essentially it just splits up. So the carbon becomes positive and becomes a carbocation, while the bromine gains a negative charge and becomes a bromine anion. This can happen because, remember, we talked about bromine being a good leaving group. It's pretty stable on its own, and so bromine can essentially just leave. And so that's the first step. First, you form a carbocation. Next, we're going to take this molecule into the next step. So next would be the capture of the carbocation. So remember, you have the CH3OH floating in the solution, and this will act as a nucleophile due to the lone pairs, don't forget about those, on the oxygen. And so what's going to happen is the oxygen lone pairs is going to come in and attack that carbon and form a bond there. As a result, after that, you get this as the product. So that is the product. And now you have a positive charge on that oxygen because it used one of its lone pairs to form a bond. And you might ask, well, why doesn't the negative bromine in the solution come and attack the carbocation? Well, truthfully, this CH3OH, the oxygen, is a better nucleophile than the negative bromine. Remember, not all anions are better nucleophiles than a neutral molecule, and this is one of the cases. And it's also important to remember that this carbocation, this molecule right there, is a very strong electrophile. And so essentially now you have this product and you have a positive charge on that oxygen, and you want to remove that. So in the next step, you essentially just take this molecule of CH3OH and just use it to remove that proton. And so let's do it out. So the final step in an Sn1 mechanism is the loss of that proton, this proton. And so what's going to happen is this oxygen, once again, is going to come in and attack that proton. And then the electrons from that bond then move onto that oxygen. And your products would be down here. And so those are your products for that reaction. And eventually what's going to happen is you still need to form the HBr from the reaction. And so the bromine anion is just going to pluck off one of the extra hydrogens in order to get neutral molecules everywhere. But in general, you don't really care. People don't really care too much about the HBr. So what you need to remember is that the SN1 is technically two steps, although I've pretty much summarized it as three. So it's two steps. It was deduced after many experiments. And finally, the most important thing to remember, tertiary substrates always choose the SN1 mechanism. And let me explain that. So tertiary substrates, which means a carbon bonded to three other carbons and a leaving group, will always choose this because a carbocation that is formed, a tertiary carbocation, is relatively stable. So, as a result, it's going to be more likely to form. Because remember, the methyl groups are donating electron density to that carbocation, to that positive carbon, in order to stabilize it. So, point is, tertiary substrates always choose this SN1 mechanism. And I'll just briefly mention that primary substrates, on the other hand, so carbons with two hydrogens and one methyl group, so something like this. Those are primary substrates, and they will always choose SN2. And then you have a secondary substrate, which is in the middle, and secondary substrates choose a mixture of indirect and direct mechanisms. So they sometimes choose SN1, sometimes SN2, and we'll talk about that more in a future video. And some final things to mention about SN1 mechanisms. So the SN1 mechanism is first order overall, which means that the rate of the reaction depends only on the molecule that has the leaving group on it. And the rate determining step, which is the slowest step, is the formation of the carbocation. And so these are just some minor details, but the most important thing is you understand what an SN1 mechanism is and how, and the mechanisms of how it occurs. And so I hope you found this video helpful. If you did, please give it a like and share it with your friends.